Welcome, Hornets, and thank you for joining me today. This is part 2 from assignment number 8, found on page 385. In this video, I will be continuing with problem numbers 43 through 51 odd, and then looking at Euler's method for 73 through 77, where n equals 2. Please do not follow the book. If you follow the book, you're going to be doing Euler's method with 10 subintervals, and you are volunteering to be in hell. So hopefully you'll join me in purgatory and you won't be feeling so bad. So we're going to be starting in number 43 since I did stop at number 41 in the last video. And number 43 has me working with a dy dx equaling x divided by 1 plus x squared. Now you need to remember that when you're working on an FRQ, you have to write the problem again. So start by writing your dy dx equaling, then separate your variables. In this case, there's only one variable to move, and that's the dx. Put it behind, and now do your integration. Don't try to integrate immediately, or they will take off credit, and you'll get nothing for all of your efforts. These 3 steps are mandatory for the AP test. Now, when I integrate dy, I get y, but in order to do the right side where we have that x over x plus 1 plus x squared dx, we're going to need to use a u sub. So I'm going to let u equal 1 plus x squared so that my du will be a 2x dx. You'll notice up in the numerator we only have 1x dx, so I'm going to have to multiply by 1/2 on both sides so that I have just the x dx which can be replaced. I now have the 1/2 going in front, and I have 1 over u du. Now we know this as our logarithmic rule, so we're looking at y equaling 1/2 the natural log of the absolute value of our u, which is 1 plus x squared plus c. Now they did not give us a particular point on this curve, so we can't find the particular solution. And as a result, 43's general solution is y equals 1/2 the natural log of the absolute value of 1 plus x squared, the quantity plus c. Now, some of you are already going to notice that 1 plus x squared can never be negative, which is going to make the absolute value superfluous or redundant. Be aware that the AP test will not mark you wrong for putting in the absolute values. They will only mark you wrong if you forget them when they're needed. I recommend you put them in anyway and cover your posterior. Let's go ahead and take a look at number 45. Number 45 gives me dy dx, and it's equal to x minus 2 divided by x. Now, the first step is to separate, so dy x minus 2 over x dx, and then the integration of dy equals the integration of x minus 2 over x dx. Now, if you recall, when we were taking our notes, we saw problems where we had the variable in the numerator equal to the power or degree of that in the denominator. When this occurs, we either have to do long division or we have to separate by breaking it up into 2 different terms around the minus. This would give us x over x minus 2 over x, and we can simplify this so that we end up having y equaling the integration of 1 dx minus the integration of 2 over x dx, which we know is our logarithmic rule. So we're now going to write this as y equals our x minus 2 natural log of the absolute value of x plus c. Once again, without a specific point on this curve, we have to leave our solution like that. Number 47. Number 47 is giving us dy dx is equal to the sine of 2x. Therefore, dy must equal to sine of 2x dx. We then integrate both sides, and we need to look at that u sub for the 2x that's inside of the sine. If I let u equal 2x, then the du is 2 dx, and we move the 1/2 to the other side. We now have 1/2 du equals the dx, and we can do a direct substitution. The integration of dy is y, and it should equal now 1/2 the integration for the sine of u du. Now we know that the integration for the sine is negative cosine. So we have y equaling negative 1/2 the cosine of u, where u was 2x. Then add c. Our answer is y equals negative 1/2 cosine 2x plus c. Number 49. In number 49, we're now working with radicals. We saw this one very recently in a worksheet that I gave you where we were working with a slope field. If you need to, I would recommend you go back and take a look. Alrighty, we're now going to write it as dy equals x times the square root of x minus 6 dx, and it leads to our integration of dy and the integration of x square root x minus 6 dx. We're not able to distribute that x into the radical, which means that we have to now change that x minus 6 in terms of u so that we can write x as a u. If u equals x minus 6, du equals dx, and x has to be u plus 6. We can now replace, giving us y equals the integration of u plus 6 times u to the 1/2 power du. We can now distribute u to the 1/2 into the u plus 6, giving us y equaling the integration of u to the 3/2 du plus 6 the integration of u to the 1/2 du. When we add our power, we're going to get 2/5 u to the 5/2 plus 6 times 2/3 u to the 3/2 plus c. And we're now going to rewrite it by back substituting our u value. Since our u was x minus 6, we put it in. Now please make sure you put the correct piece in. I can't tell you how many times not only others, but I have put in the wrong value. Sometimes I'll put in this u plus 6, which is x. That's just a stupid blunder, and I would rather have you be careful of it and watch what you're doing. Alrighty, there's our answer to number 49. Y equals 2/5 x minus 6 to the 5/2 power plus 4 times x minus 6 to the 3/2 power plus c. This now brings us to number 51. This is the last one before we move on to Euler's method, and that'll bring us to number 73 through 78. Okay, so number 51. Number 51, dy dx is equal to xe to the x squared. So I'm separating my variables, xe to the x squared power dx, and then integrate. Now, the more you do this, the easier they are going to get. That's all I can really give you as a positive here. They are tedious, and they do require you to practice, whether you like it or not. So if you don't like doing this, I recommend that you figure out how to get out of this class, because this is what we're doing for the remainder of the year. No, I don't want to do that. Alrighty, I now have my 1/2 du equals x dx, and I can see I have an x dx. So I have y equaling the integration. The 1/2 moves in the front, and I have e to the u du, which allows me to get y equals 1/2 e to the u, where I back substitute x squared, and don't forget plus c. Alrighty, we are now ready to begin Euler's method. Now, if you recall, in the notes that I gave you today, I said use a chart. If you choose not to use a chart, you are making life very, very difficult, and you have no one to blame but yourself. Now, the chart that I gave you follows the same pattern each and every single time. We're going to start with x, then y, then dx, then dy dx, followed by dy, and then the new y. We're only working with 2 subintervals. Please be aware of that. So if I'm trying to start at 0, 2, x is 0 and y is 2, and I'm trying to move to a point 1. So I'm trying to go to point 1 here. Excuse me, let's put it in the right place. Point 1 goes here, and you'll notice that I need to have 0.05 as my dx. This is because if I have 0 to 0.1, I have to have 0.05 plus 0.05 to make the point 1. Now they tell us how to find dy dx. They give it to us as dy dx, or y prime, is equal to x plus y. And this is what we're trying to do in order to find the dy dx. We will then multiply dx by the dy dx. This gives us dy. So right here you're looking at a product to yield dy. We then take the old y plus the new y to find what the new y will be. Here we go. Whee! 0 plus 2 makes 2. 2 times 0.05 is 0.1, and therefore I have 2.1. 2.1 goes right there, down in the new place, and I'm now looking at adding 0.05 plus 2.5, and that's going to give me 2.15, multiplied by 0.05. Now I'm going to go ahead and use a calculator at this point. Otherwise, we're doing long multiplication, and a lot of people will find that even more tedious. I get 0.1075. I'm now adding 2.1 plus the 0.1075, and I end up with my answer, 2.0207. Well, let's try that again. Extra decimal place there. 2.2075. And that's the answer that we're looking for. Therefore, f of, or y of, I suppose they're doing a y instead of a function. So y of 0.1 using Euler's method is approximately 2.2075. You can see that was number 73. It's different from what the book is asking us to do. This brings us to number 74. Once again, follow what I ask, not what the book is telling you to do, or you're in hell. It's your fault. I recommend you don't do it. So I'm putting in all of my information, x followed by y followed by dx, dy dx, followed by dy, and then the new y. Let's get rid of that column. We don't need it. In this problem, they tell us that our dy dx, or y prime, is going to have to be x plus y again. The initial condition is 0, 2. And we're now trying to get to 0.05. So that means that I'm going to add 0.025 and 0.025. That's going to give me 0.025 and then 0.5. We're now ready to begin. And here we go. X plus y is 2. Multiplied gives me, 0.05. And that's going to give me 2.05, which goes into the next line. We're now adding the 2.05 added to the 0.025, and we're looking at 2.075, which is then multiplied by the 0.025, and I'm getting 0.051875, which I'm then going to add to my 2.05, and I end up with the answer that we're seeking, 2.101875. Therefore, our y of 0.05 is going to be approximately 2.1018 to the 4th decimal place. Next one, number 75. This is my last one that I'm going to do, Hornets. I believe that with this work, you should be able to do all of the other problems. If not, I recommend you come in and ask me questions during lunch or after school when I'm not in meetings. We don't need that. Let's put our dy in and new y. Alrighty, so they're telling us to use our dy dx is 3x minus 2y. We're working with a 0, 3, and our distance that we're trying to go to is 0.05. So that means I am once again having 0.025 twice, 0.025, and you'll notice these should be evenly spaced as I put them into my chart. We're now ready to begin. Notice I always fill out the chart and then I start. I think you'll find that easier. We get a -6 when we plug in the 0 and the 3. So I have to multiply 0.025 times that -6, and I end up with a -0.15. Oops, wrong line. Now we're going to have to add that -0.15 to the 3, and you're going to end up with a 2.85, which goes in the next line. We're now looking at 3 times 0.025 minus 2 times 2.85, and we end up getting -5.625, which we have to multiply by 0.025. This gives us -0.140625, which I'm going to add to my original y in this line. So plus 2.85, enter, and the answer we seek is 2.7093, written to 4 decimal places. So we can now say that our y of 0.05 is approximately, remember these are all approximations, they are after all coming from tangent lines, and it's 2.7093. Alrighty, I'm going to leave the last 3 for you to try to do on your own and come in and get help as you need it. Thank you very much, Hornets. I hope this has been helpful. If you feel that this was a reasonable video, please click like. If you have suggestions for how I can improve, please feel free to write a suggestion in a comment. Otherwise, I hope this is useful. Bye-bye now, and please be safe and take care.